In this video, we're going to look at topic 87, example 3, add rational expressions with unlike denominators. So let's turn this into an actual addition problem. We have x plus 3 over x squared minus 1 plus 2 over x squared minus 3x plus 2. All right, so to add rational expressions, we need a LCM or like denominator, least common multiple. And to do that, we're going to need to factor the denominator of each expression. So the first rational expression, we have x plus 3. The denominator is the difference of squares, so that would factor into x plus 1 times x minus 1. And then my second expression, the denominator, I have a trinomial here. I need to find factors of 2 that have a sum of negative 3. So that would factor into x minus 1 and x minus 2. You would use a factor sum chart if you can't figure that out kind of off through, just visually. So if you do need a factor sum chart, you would do that way. All right, once you have your factored form for your denominators, you're going to look for your like denominator, right, or a common denominator. So I'm going to take my denominator here, create a new fraction here, and I'm going to take each piece from my first expression. And this is kind of one of the quicker ways or the most direct approaches to finding a common denominator. That's not supposed to be blue. So we have the x plus 1 and the x minus 1 from the first denominator. If I look at my second denominator, I already have that x minus 1, so I've already mentioned that in the denominator, but the x minus 2 has not been included, so I'm going to need to bring that into the denominator. And now I have an LCM. All right, I have the least common multiple, I have a common denominator. Sorry about that. So the denominator in the second expression, again, will be the same thing. The whole purpose of this is finding a common denominator. So let's color code this. Okay. Now in my numerator, I had x plus 3. I need to look at whatever is new in my denominator. So the x minus 2 was not there before. So I need to include that x minus 2 in the numerator. All right, anything new in the denominator has to be included in the numerator. On the right side here, we had 2, and then the x plus 1 is new, so we're going to put that in there. That was blue. And then the x minus 1 and the x minus 2 were already there, so we are good. Again, anything that was added or really multiplied, anything that was included as a new term or a new expression in your denominator to get your common denominator must also be included in the numerator. Okay, be careful with that. That's going to be the hardest step of this process. If you can do that, you'll be in pretty good shape. Okay, now from here, you have a couple options in what you would do with the next step. You can simplify or multiply out the numerators and then combine your fractions, or you can combine your fractions and then kind of piece things together. What I'm going to do is I'm going to put the fractions together first. So I'll have x plus 3 times x minus 2 plus 2 times x plus 1. And then in my denominator, I just copy the common denominator. All right, so just make sure everything matches up. You want to be careful that you don't copy anything wrong. So you take your x plus 3 and the x minus 2, and then you're adding the 2 times the quantity x plus 1 in the numerator. My denominator was copied the same way. Again, if you want to kind of color code it somehow just to keep track of everything, feel free to. All right, now our next step, we're going to start to do some work in the numerator. So the two expressions, the x plus 3 and the x minus 2, I'm going to distribute these. So I'd wind up with x squared minus 2x plus 3x minus 6. And if you want to put that in parentheses, feel free. And then we would add 2x plus 2 as well. Again, if you want to use parentheses, feel free. So that 2 would get distributed in. My denominator is not going to change. Do not multiply the denominator back together. It'll just create more work for you in the end. So keep the denominator expression separate. Do not multiply them back together. All right, my numerator X squared would just drop down. Negative 2x plus 3x would be a positive 1x minus 6. And then the 2x plus 2, I can remove those parentheses. And now I have this expression here. All right, everything from here is just combining terms, and unfortunately for this specific problem, we're going to have to factor again, but we'll get to that in a second. So my numerator, I will still have the x squared term. The 1x and the 2x need to be combined, so that would give me 3x. And then the negative 6 and the positive 2 would need to be combined, so that would give me a minus 4. And don't change the denominator. Keep it as is. Now, there will be times that you're done on this step, but we do need to check to see if the numerator can be factored. So we're going to do that. Use your factor sum chart. So we want to know if there are factors of negative 4 that have a sum of 3. And there are. So it would be negative 1, positive 4 would give us 3. So my numerator factors into x minus 1 times x plus 4. My denominator, keep the same. And the reason that we do this is you're going to notice, or maybe recognize, that these x minus 1s can now be canceled out. So we can reduce our expression to x plus 4 over x plus 1 times x minus 2. Nothing else can be reduced, nothing else can be canceled, so we'd stop there. The reason that you have to factor at this step is because, like we saw here, there are going to be the times where certain things can be canceled out. In this case, that was very much the case. So do check that as you go through the problems. Make sure that you're factoring at the end. You need to factor in the beginning because you need to be able to find a like denominator, and then you need to factor at the end to see if you can simplify or reduce any of the expression. Right. It's not the shortest process in the world, but it comes down to a lot of factoring, common denominators, multiplying, distributing, combining like terms, and then simplifying. If you're patient and take your time with this process, you should get the correct answer. Just make sure that you're careful with your steps as you go. The final thing we do need to look at, though, we do need to mention the domain. So the domain should be checked pretty much the whole process, but you can go back to the like denominator and start with that, and then just check through the process to make sure nothing else has been included or kind of added in. So my domain is going to be all real numbers except x equals the x plus 1. So I'm looking back here. Actually, let's go to the denominator, the like denominator. Let's look here. So the x plus 1 tells me that x cannot be equal to negative 1. The x minus 1 tells me that x cannot be equal to a positive 1. And the x minus 2 tells me that x cannot be equal to positive 2. So color code that so we know where those numbers come from. If you go through the rest of the steps, none of the denominator, there's nothing been added into the denominator, so that's going to remain our domain. We don't have to worry about any other exceptions or anything else being added into the domain. That would be it. So one more time, it is a longer process. You will get frustrated along the way, but if you just stay disciplined in your approach, take your time, check your work, you'll be okay.